Hi, this is the first video for STA5205, my Design of Experiments class. In this short video, I'll be showing how to use Jump Pro 11 to design a simple experiment, generate some phony data, and then analyze it to assess the performance of this experiment. And in particular, I'll do it with a 7-factor experiment. So you have 7 factors we can control. We can set each factor at a level in advance, and then for each of those levels, we produce a product for which we can take a measurement on the quantitative aspect of that product. So to just make it specific, imagine we're going to bake a cake, and our goal is to get a fluffy cake, say that has a maximum height in the center of the pan, is our goal, and that means just the cake itself. So here's 7 possible factors: size of the egg, baking temperature, time in the oven, say 30 minutes or 35, amount of flour, type of grease or Crisco on the pan, Pillsbury or Duncan Hines brand, say amount of butter. You could have other factors, but just for the sake of argument, let's suppose we have 7. And the idea is to come up with how do we set those 7 factors. We're going to use -1 to be the low level of a factor and +1 for the high level of factors. So temperature 350 we could code as -1. 370 could be coded as +1. Medium egg is a -1. Large egg is a +1. So forth, down to say the 7th factor. So how do we do this in Jump? Well, if we need to open Jump, and let's see, I want to open Jump via, it's in my applications. Jump Pro 11 is what we're using this semester. This is how it pops up. We open it. I don't need the tip of the day, so I'm going to close that. Jump Starter, I would use that if I already had some data. Perhaps I don't need that. What I'm going to go to is Jump DOE up here on the top. See Jump DOE. And I'm going to use something called Screening Design because we want to look at those 7 factors and see which ones are really important. So if I click Screening Design, it comes up with this template. Y is going to be my response. I want to maximize it. This is the height of the cake in the middle of the box. And I have 7 factors. I'm just going to call them continuous for now. I'm going to put 7 in here. And continuous, even though I know Duncan Hines and Pillsbury was categorical, but just for the sake of argument, let's just see what Jump would do with all continuous. All continuous, continue. And it gives me a bunch of choices, and this is why you have to take a course like this to figure it out. I meant to say, if I didn't already, that we could make as many as 16 cakes. So these are the possibilities, and then they have something called block size. Well, we're not going to do any blocking right now, so we're just going to go with 16 runs, fractional factorial, continue. And then it's going to find it for us, and we'd like to see it in the order, say, let's just sort the columns left to right, and then make the table, see what it comes up with as a design for us. Here it is, boom, it's that easy. We have factors, they call them x1 through x7, and then the response that will go in there. Let's just go ahead and put in capital A. For the factors, I'm going to call them A through A, B, C, D, E, F, G. Just kind of used to that. So here's what it came up with for a design, and if you look closely at it, and you'll get plenty of practice doing this, you'll see there's 8 minuses and 8 pluses at each of A, B, C, D, E, F, and G. And if we just focused on A, B, C, and D, you might notice that all 16 combinations are there. We could check it by doing table summary with those factors A, B, C, D by group. Click OK. You see there's 16 rows here. So all 16 combinations are there. And we might wonder, well, how do E, F, and G relate to A, B, C, D? If we say, well, let's have a look at fitting those columns, E, F, G, drop Y by remove. And then for A, B, C, D, we highlight those and do under macros full factorial, we have all the different possibilities of single letters, 2 letters, 3 letters, and 4 letters. Oh, sorry, I need this for just A, B, C, D. So first I'll just remove these, sorry. Highlight these 4, and then do full factorial. So it's A, B, C, A, C, and so forth down to D, up to the 4 letters A, B, C, D. If I do run, I'm doing a regression to see how that columns E, F, and G relate to A, B, C, D. See that column E is B, C, D, column F is A, C, D, and column G is A, B, D is equal to that. So if you run this on your own, you can study this output a little more at your discretion. So that's kind of interesting. That's evidently what JMP has figured out to do. So now I want to open a file that's already been created. I want to compare this to another type of design. I want to do an open, this one, open bake cake example. This is one that I've already created. It's effectively, this first part is the same design as what I just generated. So to save time, I've put that in here. I created a normal 0, 1 error term via formula, random normal, under random, here's the random normal. Close that out. And then y here, let's suppose we have as our true model y equals 50 plus 5 times a plus 5 times b plus 5 times c plus 4 times d plus the error times 3. And just for simplicity, I'm going to drop this thing that was in there already. We don't need that. Say OK. And then over here, on the next set of columns, I have a different set, 7 columns, A, B, C, D, with double letters. What I've done here is put all 1s in the first row, so all at the high level, and then I vary 1 factor at a time, minus, minus, minus 1 down to here. There's 7 of them, and then I do it again, replicate it, all 1s, and then minus, 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 and so on. Use the same model. Here again, I'm going to drop that cross product term. That's gone, and now we have two different experiments. So let's just do an analysis of these. First, I'll analyze the first one, fit model. It's y, and here I'm going to delete all those, and I'll do A through G. Let's look up to factorial to degree, and I'm going to do something called stepwise. Don't worry, we'll go through this in more detail in class. I just wanted to have it documented to show you what happens. We do run. Here's stepwise. It's going to pick off what are these factors that are important. I prefer to use p-value threshold. No rules, meaning any factor can go in. And let's just see what happens with this data. I click step. A shows up. Remember that was 5. Step again. D shows up. Step. C shows up. Step. B shows up. Step, and then down here it gets 1, but it's just kind of marginal compared to these. These is 10 to the minus 5th, 0, 1, 10 to the minus 5th, 10 to the minus 5th. So this one's kind of marginal. So pretty much it picks off exactly those ones that we wanted, that we would have expected based on what the truth was. And just finally, let's compare it to what's going on over here with this 1 factor at a time experiment. Analyze, fit model. We got YY. Get rid of this one. Remove it. Here, those are not the columns that produce the numbers. It's the AA through GG. Factorial to a degree. Run it. Oops, I forgot to do stepwise. Let's try again. Analyze, fit model. These guys I will put in here. Remove, delete, and here I want factorial to degree. I want YY as my response. 8, and then I need to do stepwise, just like I did before. p-value threshold, same kind of setup, no rules. And let's see what does it find if I try to run this. Step, oh my goodness, a CE interaction, that's kind of strange. Step, an AD interaction, what is it doing? A BE interaction. Step, another interaction, stops. It's a mess. So this one factor at a time experiment was a disaster. That's basically what I want to show in this video is, first off, how to construct the design using JMP, then do a comparison with one factor at a time experiments. So that's it for this one.